Alright, welcome back. Welcome to part 3 of the JBL 8400P insane amp repair. I don't know really how else to describe it, but let's get into this and get this done so we can move on to something else. I'm starting a little early today. I've been out in the sun way too much the past couple days. I just need to be inside down here and cooling off, so let's get into it. Where we left off last time, I was finishing the repairs on the bottom of the board, and I was also short a couple of components. I needed a resistor and 2 capacitors. So I was using surface mount components, and let me zoom in. I remounted the camera, so hopefully my head won't be in the video all the time. So we'll see what happens there, but my desk is just complete chaos right now. But let's get through it. So what I did was I took off all the surface mount capacitors and resistors down here, and I mounted through-hole parts. I didn't like the way that the connections were just kind of on the edges of the replacement traces, so I just took some through-hole parts, bent the leads, and these are the same values, just higher wattage rating on the resistors and higher voltage rating on the caps. No big deal, but soldering the through-hole parts on there will actually help reinforce the traces a little bit. I also decided that I am not going to smother the whole bottom of the board in epoxy. I just flowed super glue underneath all the edges of the traces and let it wick underneath it. And that with the through-hole parts soldered on top should be enough to hold it in place. The reason I don't want to epoxy this whole area is because if it needs to be serviced again, all the work that I did is going to be destroyed. So I felt it's best to just leave that the way it is. Everything's on there secure. It's not going to go anywhere, so that's why I didn't do that. So I do have the rest of the board assembled. We'll go through that real quick. I replaced the coils. Those are glued down with E6000. Should be a non-conductive glue. Replaced both high wattage resistors. Recapped the entire board. I replaced the L-tone caps with film caps. I had to wire them up a little bit differently because I can't get to the ground plane underneath them. So we're using a shared ground between those and the front 2 caps. Should work just fine. Actually, I know it works fine because I tested this once already. It works fine. So what we're going to do is we're going to take out my hacked in resistor in there, and we're going to replace these 2 caps with the correct value, and then we will proceed with finishing up the reassembly, and we'll do a live test. So this one's not going to be terribly long, but we're going to get through it, we're going to get it done, and we're going to do a burn-in on it and get it back to the guy, because I've had this for a long time, and I want to get it out of here. Not just for me, but for the person that owns it. This was not an easy repair, but the goal was to show anybody that watches these that no matter what condition your amp is in, it can be fixed. This thing was in absolutely terrible condition. There was a hole burned through the board. The board itself was becoming conductive. There was damage from leaking electrolytic fluid from all the capacitors, and it ruined a lot of the board surfaces. It caused a lot of delamination on the solder mask. So, I mean, there were a lot of issues with this board, but a little bit of patience and some work, and we brought it back. Granted, this is not the typical repair that I do. I generally try to avoid complicated repairs like this. It just chews up a lot of time, and most people don't want to wait. My rule with this is if you send me an amp that's in this condition, I will repair it, but I'll do it at my leisure, which means it could be sitting on my shelf for 4 to 6 months. If you want it and you're patient, I don't have a problem. If you want it and you're impatient, I won't do it. I have too much other things going on, but this guy seems pretty cool. He definitely wants his amp back, but he still seems pretty cool. My solder sucker's not acting cool, though. These little tips are hard to work with on these things sometimes. So I put 220s in there. These are supposed to be 330s. That's all I had. I wanted to get a quick test in. You know, when I got this board back together, I was excited to see, you know, if it was going to work or not, and I just threw what I had in there. Probably could have left them in there, but the schematic doesn't call for that, so. I don't really like to deviate too much from what the original specs were, just because then when the next guy goes to work on it, it's different than it should be. It causes some confusion sometimes. So, I will replace these caps. I will put the resistor in there, and then we'll start the reassembly. Now, I did do a few other things. These little metal pads that hold the output transistors down, I cleaned those up a little bit with a wire brush. They're a little corroded. I'm guessing this amp spent some time in the basement somewhere, wherever it was, and by sitting down in a high moisture environment, it did cause some corrosion on some of the surfaces. And then when the cap started leaking and electrolyte went everywhere, that really corroded stuff. But everything will be like brand new. Almost. Hopefully it'll function and play like it's brand new. Can't guarantee it's going to look that way. I don't know what the cabinet looks like. Hopefully the cabinet looks better than the boards do. But we're going to finish up these last couple parts. I'm doing a quick check. Yeah, see, so the camera is better. I can actually lean over and see my work a little bit, and you guys aren't looking at the top of my head, so that's good. It helps a little bit. I'm shooting the camera a little bit at an angle, but that's alright. It still seems to focus pretty. Maybe it'll focus better. I don't know. Never know. Weird things happen like that sometimes. Alright, so we have our two caps in. I'm just checking to make sure our polarities are correct, and they look good. Now we got to get that resistor that's like way, way down in there out. That should be fun. I could move this to the bottom of the board. I really need to change tips. This is not a good tip for getting the solder out of these. I'm going to go to a larger tip. And of course my favorite tip is buried underneath my mountain of desk garbage. We'll have to go to the mega tip. Yeah, when I have like a couple of days of idle time, or I'm just like extremely busy with whatever else is going on, this desk just piles up with stuff. But for what we're doing, this big tip should work just fine. Might even clean it out a little better. I think this is a number 4. I usually use a number 2. This one you probably can't even read anymore. This is, yeah, number 4. So, we will finish this up. And we are going to this one replace trace here, so we do want to be a little careful that we don't heat it up too much so I lift the trace off the board. That would not be good. I see a little piece of solder here that needs to get melted in that I missed. Couple little minor things, but we should be in good shape. And like I said, I already cheated and I already know that this does play. Well, it did play. That doesn't mean it will when I put all this stuff back in and then flip the switch again, but I hope it will. Just while I'm waiting, well, actually it's heated up. We'll get to that in a minute. So I'm going to resolder and then re-pull that back out. Much better cleanup. And we didn't want to keep the heat there too long, so here is our resistor. It's not flame proof. And I don't want to put this on the bottom of the board, and I'll tell you why, because it's just going to concentrate all the heat down there. I mean, it's not much better to have the heat packed in here, but I feel more comfortable having the heat. Let's see if we can do something with this. Let's play around, see if we can make it interesting. I'm going to grab a new resistor. We don't want, we don't want them flopping around in there. But maybe we can do something where we get it away from everything. I don't want it to cause any shorts either, so we got to be careful of that. So we'll just do a little chest. If I just stick it down from the top, it's going to be right next to the cap. And I don't know how hot this gets. If I go from the bottom, see, my standoff height isn't very high. But I do like the fact that, well, I think I'm just going to go from the top. Film caps can handle a little heat, at least better than long-term exposure to the electrolytics. I'll tell you what I will do. I'll put it in backwards, which puts the body of the resistor farther away from the caps and closer to this inductor. I don't know how much that'll help, but that might help a little bit. And I'll space it off the board just a little bit, just for fun. Just so I can get a little bit of silicone in there to seal it. So I'm going to tack the top lead in place, and then I'll trim it, and then I'll solder it on. And we're doing this just to get it positioned a little bit higher up. This was a hot section of the board, so hopefully this will help some. If not, hey, we tried. I'm happy with that. Gives it a little free space. It is on a slight angle. That won't hurt nothing. Let's solder it in and see what happens. And I'm just using the solder sucker to solder it in. It's a little bit of overkill, but that's alright. Want to make sure we have a good hot joint in there. This was already cleaned once, but since I redid these, this will all get cleaned again. And just for good measure, I'll put another few drops of super glue on there. So, alright. We could have probably left this guy in, but I don't know. This is what it originally called for. This is probably a little bit higher wattage, but they wanted a oxide film, and I don't know if this is wire wound or what that is, so it probably would have worked, but I don't know if it would have worked long term. So there we have it. The resistor is kind of spaced up a little bit. It's in there. kind of out of the way. It's not going to touch the board. I'm going to blob some silicone behind it to make sure it doesn't rub up against the control board. And I'll throw a blob in between these two caps and the inductor, and that should secure that in there. Same with this cap here and with this coil down there. I'll just, throw a few blobs down in there to kind of keep everything in place and from moving around. And that's how they did it at the factory. But first I want to clean this up, throw some super glue on there. And all the super glue is doing is just assuring that the traces stick down to the board. That is its only purpose. So you want to make sure you get a good clean. Anywhere that you exposed it to flux. And this is a non-corrosive flux, so it won't hurt the board, but I don't know how well super glue sticks to it, so I clean it out real good with alcohol anyways. And always use 91%. I know during the pandemic 91% was like impossible to find. But don't use 70% on non-circuit boards. It's got too much water in it. And the hot air I'm just using to drive off any of the moisture that's left from evaporation. Plus preheating the board a little bit helps the super glue to dry faster. And you don't want to get it too hot. I'm just getting it, hot to where it's uncomfortable to touch it, but it's not burning anything. So just the right amount of hot. And we're going to take our super cheap super glue, and we're going to put it on there pretty generously, just around the edges of the traces, because it'll wick underneath them. And super glue is composite based. Anywhere else where there's exposed fiberglass too, hit it again. It's not going to hurt it. When you go to resolder these, that'll burn right through, like nothing ever happened. Now I know there's a ton of super glue on there, and everybody's like, oh, you can't have that much. Look at this, I forgot to trim these leads. I was so excited to test this thing, I forgot to trim 2 cap leads. Alright. Let's clean up these 2 caps that we just put in. Let that super glue flash a little bit. I don't use kicker. I can't stand the smell of it, or accelerator, or whatever anybody calls it. I find the smell just totally repulsive, so I don't use it. I let it dry naturally, which I think gives you a better joint anyways. And then I just take a clean Q-tip, and whatever is still there, residue-wise, I just kind of wick it up. Once you get most of that excess off, the remaining stuff dries a little bit faster. And it's okay to smear it all over here. This is already soldered and done, so the board's not going to care. And even the vapors from this are pretty strong, especially since the board was heated. We're going to do the same thing on the top side here where there's some exposed fiberglass. Just hit it with a little super glue. And I know this is not like the certified authorized way to replace this or repair this. It should be done with replacement solder mask and all that, but I bought some of that stuff, and I bought a fancy laser, ultraviolet laser, this stupid thing, to try and cure it. It's like a UV curing solder mask. It's garbage. It doesn't cure. It turns into like a jelly, and it stays that way. Maybe my laser's no good. I don't know, but I hate that stuff. So I don't use it. Super glue works just fine. And it's nice and thin, so it like soaks and wicks into all the little areas where you want it to go anyways. If you get a little bit of cotton on there, who cares? That won't hurt nothing. Alright, so this board is officially done. It has been completely recapped. It has been repaired. The only thing that we have left to do is a little bit of cleaning and put it together. So one of the things that was in there is this junk here. And this is some kind of foam. Camera's freaking out. It's used to hold the temperature sensor onto the plate, but it's like it's disintegrated into nothing. So I'm just going to use some cheap window weather stripping that I got I think I got it at Lowe's. I don't know, I've had this for like 10 years, but I'm just going to use a little cut of this and it'll do the same thing. We're just trying to put a little bit of pressure onto that sensor to hold it down, so it should be okay. Coming up later today, I'm going to be doing a Lego video. I'm repairing an RCX for a new friend of mine. So that's coming up. That's what those parts are for. Alright, so here is the extremely heavy rest of the plate. Gotta make some rooms. My desk is destroyed. Alright, so here we have it. You can see that when the cap leaked, all the electrolyte, like it eventually burned through the board, and then all the electrolyte from the other cap like dripped down, and it actually ate the plating off of this plate down here. I hit this with a wire brush and got all the flake off of it. Like, I'm not going to grind it and make it clean like new. There's just no point. But it was corrosive enough to eat through metal. So you can see that, you know, this thing was living a hard life at some point. When them caps failed, it went really bad for this amp. So our solder glue is probably still a little, or I'm sorry, our super glue is still probably a little bit tacky. That is okay. That won't hurt nothing. Our caps are discharged. Don't handle electronics with large charge caps. These are discharged. And even discharged, they sometimes have a little residual charge to them that'll scare the heck out of you. One of the things I did notice when I took this out, it was missing a screw. I don't know why. I don't know where it is, but I will find a replacement for it in my box. I'm sure I have some. 2 grounds go to the corner. These are chassis grounds. They go under the screw that's closest to them. Don't tighten them too much so where you're gonna whack into the cap. But get them snug. Make sure they're out of the way and get them snug. White lead goes to the center. Make sure you're plugging it into the actual plug and not slipping it just behind the little silicone booty that's on the bottom there. You want to feel them actually positively click in. That is important. And even the screws are corrode a little bit. I wondered, this amp, it's possible this amp was in a flood. It's very possible. Or, like I said, it just sat in a very, very damp basement for a while, out of commission. I don't like to throw my broken stuff away. That's what I do with mine. It goes right into the basement. It sits there and waits for a rainy day. I did not recap the input board yet, so we're going to do that. Coming up next, that's this guy that you can't see because it's on the edge of the desk here. So we're going to recap that. Maybe we'll do that before we turn it on, That way I don't have to discharge everything again. But I'm going to continue the assembly and get the assembly completed. Hopefully in my spare hardware bin I got a couple of screws that'll fit. This guy looks good. Always good to keep spare parts too. Today's garbage day, and sometimes what I'll do, which drives my wife crazy, is I'll go out and I'll grab, you know, things out of the garbage and I'll just take screws and pieces out of them. Yeah, I could go up and buy them, but why buy them when like that? I don't know what that came out of, but it's a perfect fit and a perfect thread. Couldn't ask for a better fit. Alright. So, we have a little bit more hooking up to do. Hook up the input board, that's good. Everything over here I already checked, that's pretty good. Now my favorite part, cleaning the thermal goop off of the ceramic insulators. And this thermal goop's, well, it's still goopy even after all these years. Some of it's crusty and crispy, but the majority of it is still good. But I'm going to give these a pretty good clean. And I will use thermal paste on them because they are kind of gnarly. Actually, I'm going to cheat. I hate doing this because it ruins my razor blades, but sometimes it's just easier to get this old stuff off by just kind of shoveling it off. And I am using this schematic, which I don't need for the foreseeable future. But we want to get all this crud off, hopefully not on our bench. And then we'll put some new Dow Corning, I think it's 640. Thermal paste on there. Any thermal paste will really work. I don't know. I haven't noticed one brand to be better than the other. Same with computer stuff too. Some people swear like, oh, you have to have this thermal paste. I disagree. Thermal pastes all work pretty much the same. 1 degree is not enough for me to say that one is better than the other. There's too much user error involved with the application and all kinds of other things. So get as much of this old stuff off, most of it. Basically anywhere where you think it would, you know, kind of block the device from sitting flat. And then I'll grab a paper towel and clean them up. I'm not going to clean the little silicone ones, or the mica ones, I'm just going to replace those. If you don't have replacements, then yeah, you gotta clean those. But you could soak these in alcohol too, that would clean them, but it makes more of a mess. But alcohol on a toothbrush, old toothbrush, works pretty good. So I'm just wiping them down. I was supposed to do this video yesterday, but I was just extremely exhausted. I had the family over for dinner and we're hanging out, and by the time we were all done, I went to bed. I was tired. It's been a long, busy weekend. I worked on house projects for, I don't know, 10 hours on Saturday. I was burned out. And I did a bunch of stuff today too. Alright, those are clean. And the spacing on these is offset a little bit, so the two Q15 and Q11 get the ceramics. A little bit on both sides, not a lot, just a little. Just do like a little U-shaped horseshoe. And then we'll tweeze them into place so I don't get this junk all over me. Because if you've watched any of my previous videos, you know how much I love thermal paste. It's like my favorite thing to get all over my hands and all my equipment and stuff. And there you go. So just kind of get it, doesn't have to be perfect, just somewhat centered. Just enough to where it'll stick in place, and when we put the clamp on, it'll hold. And I'm hedging my bet that I'm not going to have to take this apart because I did get one good test. These little syringes, by the way, are great. You can get these on Amazon with a whole bunch of different thickness tips for dirt cheap. But I use them for everything. I use them for flux, I use them for oil, I use them for silicone, I use them for thermal paste. Basically any kind of liquid that I need to dispense in small amounts, I use them for. And they work great. Try and install them at the same height. It looks kind of goofy if you don't. And then we'll throw a clamp on there. These screws on here have seen better days too. They're kind of corroded, but this is a repair, already a excessive repair, not a restoration. So we're gonna say good is good. And we're gonna make sure that we're not shorting out to the device and that we have plenty of clearance underneath the ceramic piece. We don't want to crack those. That would be bad. And once we get it lined up and straight, wrench them down. And these have lock washers on them, so you don't have to go nuts with them, but I would install them until they sit flat. Now that gives it just the right amount of spring pressure to pinch it in there real good. And I need to zoom out because you guys can't see what the heck I'm doing. Alright, let's try that. So we're doing the two ceramic ones first. And this film cap might be in the way. Push them out of the way if it is. It is a little tight down in there. Be careful you don't strip the screws either, because these are fine pitch. Some of them might be difficult to get started, but make sure you're not cross-threading them. If you cross-thread them, it's going to be a bad day. Alright, we have two devices mounted. Now I am going to throw some silicone in between this film cap and that metal plate. Because it is kind of touching there, and these capacitors here are a little bit taller, so I'm going to put a blob here and a blob there, and that'll just kind of hold everything together. Just to keep it from rubbing. It shouldn't be an issue, but it's just one extra precaution just to prevent any disasters. We don't want any problems. All right, I need mica insulators. I have some silicone ones, but I don't like the silicone ones as much. They kind of tear. These ones seem to be a little bit better. Whether or not they are or not, I don't know. I don't put a whole lot. I just put one little dot on each of these. Slide it back behind there. And the one little dot, all that does is hold it in place. I want to make sure I get the full device so that it is not going to short. So just be careful, take your time, watch what you're doing. It's kind of hard to check for shorts in this after you're done, so that extra finesse that you take when you're putting the insulators down, you know, it'll save you some headaches and some time. If you can visually see that, you know, it's in the right spot and it's not going to short out, you're good to just clamp down and go. Alright, one more, and then we have the little bead thing. And we have the another thermal sensor. Two more screws, two more connectors, and one nut. Might be short a screw. That's okay, we can solve that problem. I have more screws. That should be it. I'm not going to put any thermal grease on the thermal sensors. They'll be pushed up against the plate. Thermal grease really is of no benefit there. If your amp's getting hot enough to the point to where it needs to shut down, there's already more problems than you're going to solve by the time that shuts the amp off. Now this guy in here was a little bent. I'm going to see if I can walk these leads over. I might not be able to. It's right next to the ceramic, so it shouldn't be an issue. It's one of those high quality manufacturing things, so we'll just make sure that it's right up against the ceramic. I don't want to risk damaging it by trying to push it too far away. And it'll be fine. There's a very slight gap there. Alright. Again, we're tightening these till they're flat up against the plate. I did locate the other screw. So we're going to pop that guy on. These were glued in place, so I'll probably put a little dab of silicone down by the wires at the bottom. This is not the nut. That is a different nut. have to come back to that one. Alright, so for the one that uses the little pad, I'm going to stick it onto one of these clamps, sticky side down, and just use the little clamp as a template to cut around it. That's about as close as you're going to get to the OEM material on there. It was some kind of foam, but this should offer plenty of clamping force to hold this guy in place. Just try and get it somewhat sandwiched in there. Make sure it's not going to touch the top of the device, and screw it in. Again, no thermal paste on here. We're just relying on the clamping pressure. And I'm going to put a drop of silicone on that because that felt like that thread was going to, or I'm sorry, drop of super glue. That'll act as my Loctite. Yeah, that thread isn't, yeah, I'm going to have to replace that. That one's going to have to get screwed and nutted on. Is it the screw that's stripped? Yes. Let's try a different screw first. Maybe we will get lucky. This one seems to be taking a bite, so we're not going to go crazy with it, but we are going to make sure it's screwed down. Now for these wires, I don't want them right up against that edge, so I'm kind of going to roll them down in there so they're not rubbing. Alright, we need a screw and a nut. I don't know where this nut is from. It might be from that, but I have one small screw, so I'm going to guess no. But I should have something that'll work in here. Luckily, KLIPSCH uses a lot of screws that have star washers and stuff on them, so we should be able to get a good connection on that last little thermal device. Matching the threads will be the most difficult part, because half of this junk uses metric and half of it uses standard threads. It's like they couldn't figure it out when they were putting this all together, and somebody's like, well, we should maybe use this thread, and then they changed their mind. So yeah, don't tell anybody. This is going to be a hybrid. We're going to put a little bit of KLIPSCH parts back in it. If I can find a screw that fits. So far I'm like 0 for however many I've tried. Alright, this one will work. There we go. So we have to get the thermal sensor in. I'm going to use a nut with an integrated star washer, and that's just holding this last thermal sensor in. And that will replace the screw that is stripped. This was probably the one that was on the nut originally, and that's probably why it got all stripped. just for the heck of it now, I am going to throw a drop of super glue on all these threads. Lock it in there. Why not? The nice thing over with super glue over Loctite is super glue releases with heat way better. A lot of the amps you work on, they have like some kind of plastic that's like melted on there. That stuff is terrible. It totally destroys the screws. Alright, we're going to save the nut because I don't remember where that went. And we're going to get rid of all this junk. Those screws are from something else. I know what those are from. Alright, recap time. Recap the input board, and then it's time to test. I can't believe 45 minutes went by already. Thought we were making good time today. I am going to change my tip back out. Let's see if I can find my other tip. Just a quick search through the mess, and the answer to that is no. We will use the large one. 1, 2, 3, 4. There's 6 caps on here, so nothing crazy. I am going to switch though. There's some tight clearances on here, and I don't want to melt everything on the board. I just want to get these off, get them replaced, and be done. Not that I don't like this amp, but it was a lot of work getting here, getting to this point. Waiting to heat up again real quick, and then we will finish up on these 6 on the input board. I don't do these generally, I just leave them alone. They're large non-polars for the audio section on the bypass. I've really never seen them go bad. I mean, I'm sure eventually they do, but I just don't use them enough to justify keeping them in, and I've never seen a problem with them, so I just leave them alone. And of course, they don't use the same values. 10 microfarads, 16 volts. I know we got that. Actually, don't. We have 25s. No, we have 16s. I'm running out of space for all these cap values. I'm going to heat up my other iron while that's going on. I'm going to pull some of these other ones out. It's 22 at 25 volts. Now 22 at 25 are hard to get, so I usually do those in 50. Sometimes you don't really have a choice. Certain values are just non-existent. These input boards really don't need to be recapped. I mean, with the age of it, they should, but generally these caps have a pretty easy service life, even if the amp is left plugged in and on. They're in a very low heat area of the amp. So if you want to cheat, you can get away with leaving those. I'm gonna do it just because I've done everything else on this, and I don't want to give this amp any reason to hate me. You know, double and triple check your polarities. Make sure that everything you're putting in is going in the right way. Can lead to some frustrating problems if you put a cap in backwards and you're trying to figure out why the heck this thing won't sound right. And it's all because of a cap that wasn't properly reinstalled. So, we're almost there. We're almost to the finish line with this. I hope everybody that has tuned in so far has enjoyed it. I generally, I don't really do a lot of these. I had a request by someone like, hey, have you ever done any of these? I said no. I said I'll try it. And I've worked on a few. They seem to be popular. They're definitely popular with failing. But I don't really do a lot of them. This is only the third one that I've done for this specific model. The first one was pretty easy. It had some blown components on the Class D power supply control board. This one had a hole burned in right through the board, and the other one that I have that I'm hopefully going to finish up this week had a blown inductor, and I was finally able to source the appropriate wire to rewind that. So you can't, some of these components you can't get anymore. Like this transformer, when that transformer goes out, you won't be able to find an exact replacement. You'll be able to get one similar, probably make it work, but they don't even list what the specs are on this thing. So you kind of got to guess. I'm sure it's in the manual somewhere, what voltages it wants to see. The transformers are kind of a dying thing. I'm going to find my polarity on that guy. Negative up. And all these are filters for the incoming power, for the plus minus 15 to control all the op amps and all that stuff. I believe that this general amplifier section is used on more than one model of the Infinities. I think a lot of the powered tower speakers use it, and the input sections are really all that differs. It seems to be a pretty robust design. It's got a lot of power, but they definitely blew it when they used those LE-tone caps. The LE-tone caps are the main reason of death in these things. I don't want to say they're the only reason, but I have to work on a few more to see what other failures there are. I think the one that had the power supply control board, this guy go bad, I think that was like a power surge or a lightning spike, because it was a very odd failure. One of the control trips internally failed. Last one, and then we can put the juice on this thing. It'll be interesting to, I think I'll throw the little cheap, if my battery's charged up enough, my cheap battery-powered scope on this thing so we can look at the waveform. Alright. A little bit of cleanup. Turn off my irons, and we will fire this thing up and see what we got. Get my solder out of the way. Get some caffeine juice. Alright. Everything is in. Everything should be good. Nothing appears to be shorted. That doesn't mean that it isn't, but I'm pretty sure it's not. I need my kickstand. That's why I had my tape out earlier. That's my kickstand. Now I have the switch on the plate off. I'm going to use my remote switch. If I can find the power cord, it seems to be wrapped around my chair. Severely wrapped around my chair. How the heck did that happen? These things have a really long cord on them too. It's got to be a 10-foot cord. All right, my power is off. Plug it in. We're gonna hook a speaker up to the outputs. I'm not really worried about polarity. I am gonna turn this to the side so I can get my little baby scope out. Now I'm going to power it up to here at first. I don't want to hook it up and then have it fail on me because then I'll feel bad. Alright, I have it in LFE mode. Crossover is going to be at 150. Phase is going to be at 0. And we will feed it input. 32 hertz is what we're going to start with. I am going current limited first, and then we'll see what happens from there. So here we go. I have a dim glow on my bulb. I heard the switch. And I'm not getting any sound. Let's turn the power off. Double check, make sure everything. It could be the ground in my audio feed. Sometimes that does not play nice. Let's try again. We have power glow. Make sure it's not my wiring. This thing's making a liar out of me. It did work. I promise it worked. Let's hit it off. Let's take a look. What does it not like that it did like before? So we have our connection. Our connection is good. Our connection here is good. I can't tell if I saw smoke or not. Resistors are not warming yet. Nothing is shorted. My caps, I believe I installed the right way. I verified that. Transformer power is good. Alright, let's fire it up again and see what happens. We'll go current limited again. Make sure my speaker's actually connected. That's important too. I know part of it's working because I am getting the relay click. I'm not getting any glow on the bulb, which means that audio and power are not behaving. Fuse is good. Let's switch my audio signals just in case it's my cord. This cord has been ran over a few times by the chair. I have 32 hertz going out. I'm actually going to kill power, wait for the relay to click. Relay's off. Relay's on. Alright, troubleshooting time. What did I miss? And why is it not behaving now? All of our caps are in. Check the speaker cables. Those are in, they seem good. I'll double check the thermal sensors. Yeah, I know the outputs are insulated. We don't have any short conditions on there. I know the first time it was a little temperamental. Let's power it back on, feed it the juice. See if we can let the smoke out. It's definitely trying to work. Double checking all my polarities on the caps I put in. They all look good. I'm pretty sure I have audio coming in. I'll reset my signal generator just in case. I'm not getting any volume. Man, that sucks. Well, I thought we were going to be done with this amp. Apparently not. Now it's going to drive me nuts. We're not getting output. The relay could be suspect. Just checking the resistors to see if they are warming up. One of them is, one of them is not. I did have an issue the first time with the voltage rails. I was not getting one of the rails. So I'm going to check that first. Let's see what we got. So for the outputs, something does smell a little hot. And that could be the resistors. I'm not quite sure yet. But we're going to check voltages first. So we're going to look for ground, which is pin 7. We're going to look for negative 15, so 6, and that's pin 5. We have negative 14.96, that's good. Now positive 15. Okay, so on that one I'm only getting 5 volts. So the positive 15 rail is causing me some headaches right now. And if I remember correctly, that was the one that was giving me headaches last time. Between the two, I only have 9 volts, which seems a little weird. Let's see, ground. I have negative 5 and negative 15. So we're missing our 15 volt rail. I don't know if that is one of our op amps, if that is our control board. I don't know what that is. I'm going to disconnect speaker. Try again. Current limit. We're going to go between pin 7 and ground, and 6 is protection. Let's see what we have at the protection pin. We have negative 5 volts there. That should be positive 5. Negative 14, negative 5. So let's disconnect this. So the relay is going to shut off when you pull that out. And let's see what we got. I want to see if we have power without the input board. So we're isolating the input board. So we're going to check ground. That's 7. This is 5. We have negative 15. Now we only have 1.5. So we're missing the 15 volt power supply. Unfortunately, I think the board's got to come back out. Let's see, let's take a look, and I'm going to pull up the schematic. See if I can find out what the heck is on that line. And like I said, I saw this before, and the problem went away, so I didn't think there was anything to worry about. Now there's something to worry about. And it could be a component that's iffy, could be the regulators faulty. There's a lot of things it could be. We know it's not related to the input board though. And stand by while I look at the schematic. Alright, we have... There's two 15 volt supplies on here. There's a switching 15 volt supply, and there is a standard 15 volt supply. Let me see if I can share left screen. Hold on. I'll put a schematic up just because I can. Bear with me, I gotta switch screens here really fast. Alright, left screen. Alright, here's the schematic I'm looking at. And we can see that we have AC coming in. These are the plugs that go to the amp board. Here's the two really large caps. There's some smaller filters. These are the rails for the positive and negative of the amp. And then we have these supplies right here. These shunt regulated supplies, which is plus and minus 15. Then over here, we have a step down regulator, which looks like the mute circuit controls part of that, and that also gives us a 15 volt supply. It's a little buck regulator. I don't know what feeds that. Looks like it's fed from ground and the negative rail. So there's a 15 switched. And then there's our relay, but that's not the problem. So our problem is either with the plus 15V or the 15 switched. So I am going to keep cracking away at that, and I'm pulling the schematic off because I need to be able to see what's going on here. I need the big screen. Alright, let's see what goes to that port on the board. Is that 15 switched or is that 15 regular? That just looks like regular minus 15. I don't know where the 15 switched goes. So the problems with the, I'm going to guess, is with the shunt regulator on the 15 volt side. And it's on the positive side, so that's probably either the actual device is bad. There's a resistor, a 470 ohm resistor, 5 watt. I don't think that's bad. But there's also a Zener diode in there. So it could be the Zener diode, or it could be the actual switch, or it could be any of the connections in between there. So I will start there. But I think once we get the 15 volt back, this thing will be happy and back in business. That's probably something I did, bad solder joint, something. I don't see any reason why it shouldn't come on. I'm looking for the 15 volt switch signal right now. And that comes from this control board here. The regular 15 volts comes from the actual main board. There's a couple of 15 volt switched signals on this board. And then it looks like the 15 volt switched is driven by the mute circuit, and the mute circuit controls the power to this guy, which drives the Class D part of the amp. I believe that's labeled on the board. I can get to the pins on this side. I can't get to the pins on the other side. Let's see if they show what pins are which. Probably not. That would be too nice. They do take regular 15. And actually, I'm mistaken. The 15 volt switched is over here by U6. But if there's a problem with the regular 15, the 15 volt switched will probably not turn on. Let's see what enables that. I think the mute circuit controls that. Yes, step down regulator. So that's driven by mute. So if the regular 15 isn't working, the mute's probably going to be on. Which means the amp's probably not going to be driving. I'm going to start with the regular 15 volt supply. So R78, R79, and D2 is where we're going to check. Just for the heck of it, I'm going to power this thing back on again, because the last time I did that, it just magically started working. and then it becomes an intermittent problem which will drive you to the point of insanity. But just for the heck of it, because this is what this is what happened last time, we'll do it again. Make sure that there is no power. Let's plug our control board back in. Fire it up. No juice. No amp juice. Alright. Kill that, let it bleed off. We gotta take the amp back apart. You know why that happened, right? That happened because I put those drops of super glue on there. That's exactly why that happened. I will be right back. I am back. I had to get some fire. And I'm just going to hit all the spots that I glued. Not a lot, just enough to heat them up just a little bit. You don't have to go crazy, but that will should allow the screws to back out. And as you can see, it does. Now remember, our large caps are still charged. We have to be a little careful here. I am not sure if there's an easy way to drain those without just pulling the board. I can try. Yeah, let's try and do this. We'll try and see if my probes will get down in there. Our shorting probes. We don't want to, you know, take it to the metal. They are not going to be long enough, so we're just going to have to be careful pulling this out. You know, the transistors, we want to make sure you don't allow them to short to the one next to it. Just be careful. Take your time. There is voltage in here. If you feel more comfortable, put a pair of pliers on there so you don't have to stick your fingers down in there. Yeah, we can do that. Just grab the top of the heatsink with a pair of pliers to stabilize it. Back the screws out. And I believe those caps do have some internal resistors, or there's a resistor on the board to slowly drain those, but you know, you just want to be careful. You don't want to get shocked. Getting shocked sucks. So we have everything but 15 volts. And when I first played around with this, we had everything but 15 volts. So something is, yeah, don't do that. Don't drop metal onto the board. That's no good. That's how you take a complete repair and you turn it into a brand new repair. By dropping heatsink things onto the board. I'm going to check our ferrite bead down there. There is a chance that that could have been damaged. I doubt it, but there's a chance. And you can see super glue is a decent thread locker. It's not permanent at all, but it does work pretty good. I'm going to pull our power leads. One of the things I have not done for this amp yet is made an extension cable so I can work on this outside of the chassis. That might be coming to a future video. I believe that these use the same connectors that one of the KLIPSCH uses, so we can check that out. So one of our 15 volts is missing. Why? What did we do wrong? What did I do wrong? You guys didn't do anything wrong. I did something wrong. So I'm going to try and leave the heatsink or the insulators on the board. It's not always possible to do that, but I'm going to try. Sometimes they just want to stick to the device. Alright, we should be free and clear, and we're going to lift it out carefully and straight up. The first thing we're going to do is discharge the caps, or make sure they're discharged. Alright, and they are discharged, so we're good. Little caps you don't need to worry about. Big caps, you want to make sure the big caps are discharged. So, this is our switched 15 volt supply. Our other 15 volt supply runs off of this side of the board here. So let's see if we can trace this circuit and see what's happening. Nothing smells out of the ordinary. That's a good way to check sometimes, you know, just give it a sniff. Use your nose. If you got a good nose, see if you can smell something burning. See if you can smell something out of the norm. It's a good way sometimes to see. And it could be something totally unrelated. It could be like one of these op amps on here is just like acting up and getting crazy. There's a lot of different things it could be. Checking the status of, you know, the things that we recently touched and worked on. Make sure we didn't overlook something. I didn't think that we did, but you know, some of these components were previously damaged and we're still assuming that they're all okay, so that's something else to think about. So, alright, so V plus comes off of our capacitor positive side, and that is this side here. So this striped rail here is V plus. It goes into this connection here, which is our coil. keep getting thermal paste on me, so I'm going to keep getting annoyed and upset. Where else does V plus go? It goes through our dial bridge, through the two big capacitors, then it goes through two small capacitors, and it hits R78. R78 is on this side of the board. R78 is 470 ohms and 5 watts. That's this big guy right here, 470 and 5 watts. So on one side of that resistor we should have V plus, and on the other side we should have V plus. That feeds a shunt regulator which is driven by D2. So where is D2? Q6 and D2. Let's find Q6. This must be Q6 right here. And that's where he goes. And there's a couple of smaller resistors on the bottom. One should be 3.3K. Let's first just check our connections. If nothing else, we'll get a little practical troubleshooting out of this. The only thing that sucks is this plate weighs like 40 pounds and it takes up a lot of my bench, but we're going to need that. Alright. So we're going to go into continuity first. And we're just going to start checking things. So we should get positive going into there, and we do. Into one leg of our resistor. We'll check the value of our resistor and make sure that that didn't burn up. Oops, I don't know what just happened. Meter freaked out. Alright, it should be 470 ohms. 466.4, good enough. So now we're going to check between the two legs on the top. I am not getting that value. So I'm getting it at the bottom, but when I come up to the top, which is weird. Oh, you know why? Because I put super glue on the top of the board. Let's try and poke it a little bit. There we go. 466.4. And if I poke that a little harder, there we go. So see, super glue is a good insulator, and it's better than solder mask. We're going to measure this resistor here. This should be our 3.3K, and I'm getting 3.402K. That should be good. Let's check our Zener diode, which is this diode here. This should be D15. I'm going to go into diode check mode. Oops, helps if I'm checking the diode, not a resistor. I'm showing 0.66 volts. 0.7 volts. It's hard to check diodes at the circuit, but sometimes you can just check and see if there's a short. On the output side of that, I have another resistor. What's going on with that guy? I don't know where this guy goes into another diode. I'm going to have to make sure that this is our Q6 part that we're actually looking at. So bust out our trusty cut up and filthy schematic here. Here's a cleaner one. Straight out of the garbage bin. Alright, Q6 is indeed the guy we're looking at. That's this guy right in between the resistor. And if I look on the bottom side, the resistors are on this far side here. So this is our big resistor here. Remember, everything's upside down. That should be Q6. So this is D2. which is the diode that we're looking at, R79, which is that 3.4K resistor we're looking at. Let me turn the board to match there. So our power comes in, it goes through the big resistor there. There's our diode, our Zener diode, right here, D2. This is our R79. This is R192. I don't know what that guy goes to. That's one we were questioning. So I will look for R192, and the one on the opposite side is R14. I don't see either of those in this power supply, so I'm going to see what those guys go to, and then maybe see if that's where our problem could be coming from. So I'm going to do a search. Sometimes these PDFs you can search for stuff. And if your computer is not fast like mine, it'll crash. Try again. Control F. R14. R14 is not even a real part. Although it shows it there. Just try R192. It won't find it on the schematics for me. So I must search. It's not in the power supply section. It's going to be on the amp board, not the input board. Still looking. It's not by a connector. Looking at the actual power supply now. I wish these were labeled too. It would be really nice if they like said, hey, this is the input section, this is the control board, this is the output. They don't do that. You gotta kind of figure that all out on your own. So I'm still looking for that resistor. I have the control board, that's what I don't need. I need the amp board. Okay, I found R14. R14 is AC present signal, and it requires a positive 15 volts coming in. So that's just current limiting for that. That feeds the control board, says yes, we have power. So that's not of interest. It's 33K. We can measure it though and make sure it's right. I guess if it wasn't getting AC present, we would probably be angry. So R14 is this guy here. I'm not getting a reading on that right. Okay, I'm getting 32K in circuit. That's probably going to be okay. The other one that was connected into that was R192. R192. 192, which is not part of the relay circuit. It's not part of the shunt or the switch circuit. It's got to be somewhere in here. It looks like an important component. We can just measure it too, just to see what it is. And I could also be reading that wrong too. Let me just look on the actual schematic, or the actual board printout. It is R192. We'll just make sure its value is correct. R192 should be 1.3K. And is this guy? After the diode, or before the diode. 1.01K, we're going to call that good. So our problem is either going to be with the diode or it's going to be with this switch. So in order to trick this, I think I'm going to get the bench supply out. And see if we can force a 15 volt supply out of it. So that operates between standard ground and V plus. So what we can do is I'm gonna use my bench supply. I'm gonna take ground to the common, which is in between these two caps. I am gonna put a current limit on my power supply. Because I don't want this thing to right away just rip and start charging the cap. I want it to go slow. And I'm just going to go to this lead of the cap, or this resistor right here. So I'm going to clip that on, and that will start charging the positive cap. I'm going to start jumping up the current a little bit. Now I'm going to start hitting the voltage. And I took it up to 30 volts. 30 volts should be enough to see what's going on here. So let's set our meter to voltage mode. And I'm sorry I can't show you this on the screen, but I can do this. I don't have one of those fancy meters that everybody else has. But I like my Radio Shack meter. Alright, here we go. Let's see. So into that resistor we have 30 volts. Coming out of that resistor, we have, is that, I can't, yeah, 28.25 volts. It's hard to see the decimal on the screen. So we are getting a little bit of drop over the resistor, that's fine. From there we go into pin 2, which is the center pin of Q6. So let's make sure we get power on pin 2. Carefully probe it out. It's showing we got positive 15. So this guy is regulating. At least the Zener is regulating. Output is pin 1. I ain't getting anything on the output. Wait. 1.1 volts. That's no good. That should be 15 volts. Let's see what we have on our plus 15. So we should have 0 volts on our ground, which we do, 0.000. So it goes ground, then protection, then negative 15, which we shouldn't really show anything on, which we don't, then positive 15. 1.1 volts. So the problem, I think, lies within Q6. And the reason I say that is because the Zener diode is clamping the voltage on pin 2 to 15 volts. So if I go back to pin 2 here, and we look at pin 2, we've got 15 volts right there. The only thing that can generate that 15 volts is the Zener diode. So the Zener, I believe, is good. I'm going to go to pin 1. We're not getting our voltage out. Pin 3, pin 1, we're not getting anything. We're getting it on pin 2, I'm sorry, but we're not getting it on pin 3. Pin 3 is actually the gate though, so hold on. Maybe our gate's not firing. Let's, our common is our big plane in the middle here. This is pin 1. Pin 1 comes off this resistor here. Pin 1 is our output. We're only getting 1.1 volt out. That's no good. Pin 1. Pin 2. Pin 2 is our input. Pin 2, we're getting 15 volts. So pin 2, we should have 15. We should also have 15 volts on pin 3. I'm getting 28 on pin 3. So either I'm not understanding this correctly or I have the pins read out wrong. Let me pull the datasheet up for this device. MPS W06, which I believe can be switched for an MPS A06. Unless the W is a higher wattage. These are obsolete. You can't even get them anymore. Datasheet. So, okay, so we're correct. So the pin out goes pin 1, pin 2, pin 3. Pin 2 is the base. And my limited knowledge of electronics could be causing me problems here. I know that's kind of weird for somebody that works on amps to have limited electrical knowledge, but I'm pretty sure that, let's see if I can, I'm going to set this up to share my screen again. Give me a second here. I need to add a scene. We'll call it right screen. Stand by. Right screen. Okay. We're going to add a source. Display capture. Create new. Okay. Okay. How's that? So at least you can see what I'm looking at. I need my big screen. So here's where we started. We started over here. This is our big transformer. These are our little wire terminals going into the board. We went through the bridge rectifier, and I have my bench supply hooked in here where this white guy goes. That's basically our ground for the entire power supply. It's even grounded to the plate through one of the screws. So that's our 0 voltage spot. Alright, so we don't have this 15 volts here. This 15 volts is missing. So somewhere in this section here is where the problem is. We checked the resistors are good. The Zener diode seems to be functioning, but this guy does not seem to be behaving. I don't know if this is drawn on there correctly. I would assume that it is, but it looks like we get the main power coming into here. And you have the Zener and this resistor right here, which makes a power supply. So between pin 2 and here, we should get 15 volts. And I believe between pin 2 and there, we do get 15 volts. There and pin 2. I gotta switch back to my display here so I can see what's going on. Alright, we're looking for 15 volts between ground and pin 2. And since we're working with low voltage on our bench supply, it's okay to be probing around in here. Alright, there's my 15 on pin 2. I'm going to check on the top side also just to make sure. 15 volts. Okay. So now on our output side, which is pin 1, we should be getting 15 volts out. I think on the gate we should be getting some voltage too, which is pin 3. I'm going to have to read about shunt regulator so I can explain that better. So they do have this schematic drawn wrong. So on the data sheet, pin 3 is on the right side. They have pin 3 connected directly to the resistor on here. That's not correct, because if you look at the schematic, let's go back. There's right screen. Let's zoom in. Boom, boom. If I look at this, the 470 ohm resistor shows that it goes directly to pin 2. If I look on here, the 470 ohm resistor goes to pin 3. So they have pins 2 and 3 swapped. They might have all of them swapped. I don't know at this point. But either way, I know that the Zener diode seems to be working. It appears that this transistor is not working. Because if I check the Zener supply between let's just go from here. Let me show you what I'm doing. Sorry, I keep forgetting to switch. So I'm going to go from the leg of the resistor, the output. We know that we have 28 volts there because there's a little bit of a voltage drop going through. Right? So we have power going there. Between there and ground. So that is connected to pin 3. It's very possible that this device is in backwards. I don't recall if I took it out or not, so I'm going to verify that before I say anything else that could be deemed as ridiculous. Okay, I'm not. The sheet that I have says that emitter is on the left side. It goes emitter, base, collector. And if I look on the schematic sheet, this is the base. So this should be pin 2. This is the emitter. This should be pin 1 and the collector. So they have 2 and 3 are swapped on here. This is why you got to have at least a little bit of understanding of how this stuff works, because when the data sheets and the schematics don't match up with what's going on, you could be in trouble. So maybe the data sheet for this device back in the day was different. I don't know. But if I go to the onsemi data sheet, it says emitter is 1, base is 2, and collector is 3. If we go back to this guy, we show that base is 3. So is the base 2 or is the base 3? I don't know. But what I do know is I need to find a part that I can swap that out with so that I can try to get this 15-volt supply back up and running. I am going to verify that all the connections are good. I'm going to actually turn my bench supply off. And we're going to just make sure that we don't have any missing connections. So to do that, I'm going to go in continuity mode. Switch back to the top here. Alright, so we're going to check that our output of the resistor does go in to at least 1 pin. And I'm not getting a beep. Let's check the top though, because I did super glue the life out of that. Alright, so we are getting power going into pin 3. The base, which is pin 2, again we'll read from the top, does go to the Zener diode, and our output, our pin 1, does connect to this resistor, and I don't think it's supposed to go anywhere else, but I'm going to double check. No. So it goes through this resistor and then it branches off all over the board. There's another diode. We can check and make sure that this diode is good. Let's go to diode mode. .8 volts. That's weird, but alright. So as long as you get around 0.5 in at least one direction, preferably the direction where the ground is on the stripe side of the diode, it's probably good. We could cheat, and I could feed in 15 volts to the output, and we can measure it just to make sure that that diode's allowing it to pass. And why don't I do that? Just for a sanity check, I suppose. I want to ensure that everything is working as it intended. So the other thing that we can do too is by pumping 15 volts to the output side of that device, we can see if there's anything down the road that's bad or shorted, because our power supply is going to show a really high current. So I'm going to turn that down, flip the power supply back on. I'm going to turn my voltage down to 15 volts, right on the money. Turn the current completely off. And we're going to go to the output side. Which is pin 1. And we'll follow along in the schematic here. I don't know, maybe this will help somebody going through it like this. Doesn't hurt to explain it. So I'm feeding 15 volts right here, right where it should be. And it's going to be hard to do this with one hand, but I will try my best. And we're going to measure and see if we have it on our pin down here where we're supposed to have our power. So here's the 15. Let's give it a little bit of current. Alright, a couple milliamps, just enough to see what's going on. Alright, so I'm drawing 2 milliamps right now. And I'm going to check on my meter and make sure that I'm getting that passed through. I'm getting 1.7 volts. Why am I getting 1.7 volts? Checking on the bottom side of that diode. So I'm not in current limits, so I don't think I have any shorts. It could be because I'm not getting a good connection. It's really hard to, probe some of these. Let's try again. Alright, I'm on pin 1. Now I am checking for... Helps if your meter's in the right setting. Let's try this again. So I am only getting 2 volts coming out of this. I'm getting 15 off of the regulator where I'm tying it in. $15 at the resistor. Only 3.9 after the resistor. So it could be our resistor on the output is bad. We're definitely not getting the 15 volts we should. So let's go back and show you where I'm looking here and zoom in. Where's my remote? So I can go in a little farther. So what I'm looking at is, and this is just my little power poker. I have my alligator clip on there. I'm putting 15 onto pin 1 of this device, and I'm trying to see what's coming out of it. Now, I should be able to see 15 coming all the way through, but when I feed 15 in there and I measure at the top of the resistor, it's not behaving now, of course. Let's catch this on the top where it's a clean connection. Alright, at the pin, it's only showing 9 volts. At the top of the resistor, okay, now I'm getting 15. That must have been, I'm reading through some glue. At the top of the resistor, I'm getting 15 volts. At the bottom of that resistor, I'm only getting 3.9. So that means I'm only feeding 3.9 into this diode, 3.3 on the other side of the diode. So this guy here is causing me some issues, possibly. So I want to remeasure that resistor. So I'm going to flip over to ohms. I don't have this powered on. That's R14. We measured R14. I thought R14 was good, but maybe it decided to stop behaving. Now there are two other diodes, D13 and 14, which could be causing the problem. Let's see what we got here. Alright, it appears we're charging a cap up. So sometimes you can cheat if you're charging a cap up that's on that line. Just short it out. Remember, we're using low voltage from a bench supply with current limiting. Short that out and try to remeasure. So I'm not getting what I would call the best results. Passing through there. So this trace comes out of this device and it goes into this resistor and passes through. So if this resistor is faulty, that could be the problem. So maybe the regulator is okay and we're just not getting anything out of that regulator because this resistor has decided that it doesn't want to work anymore. And just measuring across this device. So see, now I'm getting 32.8K. Poking it right there. So is this thing bad or is it not bad? When I go to the base of the diode in here, $32.79K. So what I'm going to do, I'm going to resolder that just for the heck of it. If I need to replace it, I'm going to replace it with the through-hole part. It could be faulty, I don't know. But I'm going to make sure that it's soldered in there good. And just a little touch up. So let's try that again. And we're going to measure across, and I'm looking at the meter. You guys can watch, you know, me here. I'm getting 26 26K in one direction. I'm getting 32.8K. So that's probably all right. Let's measure it from this leg. Maybe it could be a bad trace, maybe. $32.8K. 32.8. So what I'm going to do is I'm going to hit the rest of these legs again. Just refresh the solder a little bit. Maybe, you know, bad solder joint is possible. I didn't redo these joints here. I'm going to hit this diode, and then I'm going to hit the first leg of this device. wife just screamed for some reason. I don't know why. Hopefully I don't have to go upstairs. Alright, 32.8K. So hitting it with some solder may have helped, may have not. I'm not sure. It appears to be behaving a little bit better. So we'll go back into voltage mode and feed it some voltage. I don't need my poker anymore. I don't think. I should be able to just tap it on that one line. The hardest part is getting a stable ground. Alright, we're going to check at the bottom of the diode, which is here. And I'm going to just put it right to pin 1, which is the output. And I'm still only getting 3.8 volts going across there. I'm not hitting current limits, so I don't know why I'm not getting that voltage. Unless the transistor is bad. It's very possible that transistor is toast. But it's weird because I'm not getting any. Well, on the other side of the resistor here, I'm only getting 3.9. So if that resistor is good, and this diode is good, that means that somewhere on this side of the supply is bad. So I'm going to go back. I'm going to check the pin out on this. So it goes input, ground, protection. Input, ground, protection, negative, positive 15. Input, ground, protection, negative, wait, Q8. Q8 is negative 15. One, two, three, four, five, 6, 7, 8. So there's 8 is input, ground, protection, negative, positive. It's the fourth one over. So it should be this guy. Where does he connect on the top of the board? I need my red paper. 1, 2, 3, 4. That has a trace that goes on the top of the board all the way to the emitter, which is pin 1. That should be a direct connection to pin 1. Let's see if it does. 1, 2, 3, fourth one over. Direct connection. Pin 1. It's not a board issue. So that maybe the protection circuit we were measuring in the wrong spot. So let's try that again and just see if let's put our voltage back up. Go to 30 volts. No current. Alright, we'll give it our power. Start ramping up our amps till we hit our 30 volts. And let's see what we got here. On pin 1, helps if the meter is showing you voltage, by the way. I keep forgetting to switch that over. Alright, pin 1 I'm showing 14.9 volts. Pin 2 I am showing 0 volts. Pin 3 I am showing 23 volts. So I am going to... Oh man, I didn't realize I'm making a mess with thermal grease. Alright, so I am going to recheck that. I'm gonna hit all three of these legs and just resolder them. Just maybe it's a bad solder joint. It's somewhat unlikely, but I'm gonna hit them anyways. Forgot about the thermal paste on those darn things. Now I'm getting it all over my work mat. I hate thermal paste. Alright. Let's try this again. So we're looking at this device right here. And that device is on our schematic right here, Q6. There is an error on this. 2 and 3 are actually swapped if you look at the data sheet for that device. So careful there. But we're looking for 15 volts out on pin 1. That's what we were missing before. So if we get 15 volts out on pin 1, I think we can put it back in and try it out. I'm not 100% sure what's causing the issue yet, but the bench supply is going to feed it for now. We're going to take 30 volts. That's what happens when the cap charges and you don't current limit. You get a little spark there. So we have coming into that, let's see if I can get my meter in the screen. Let me zoom out a little bit. I need more workbench space. Can never have enough space. Let me slide all this out of the way here so we can see what's going on. Alright. I know that's hard to read. There we go. A little bit better. So I'm going off the common ground out of our resistor, and we're getting 23 volts. We're getting a 30 coming in, so there's going to be a little bit of a voltage drop going across there. So we can eliminate that and just go right to it. And we have 30 volts now coming into that transistor. We should have 15 volts on pin 2, which is the base, which we do. And on our out now, we have 14.2. So if we check over here on our output, we have 14.2. So if you factor in the voltage drop going through the diodes and all that, it appears that maybe it was just a loose solder joint. This resistor did seem to measure still okay. Everything else seems to be good, so I think I'm going to put the board back in and see what happens. I might, you know, while I have it here and I have it out, I'm just going to run over some of these other components, because if it is a bad solder joint from the board being corroded, let's not overlook that. Little leaded solder never hurt nobody. At least as far as I know. We know the Zener diode's working alright, so we're going to stay away from that. I don't really know what's going on here. There was like a little blob. Well, just enough to clean some of this up. Hit the other side of this diode. We did the large resistors already, so I'm sure that's okay. This is the area that's has to deal with the 15 volt supply, so let's see what happens there. I'll turn off my bench supply. This time I am not going to screw the transistors into the heatsink. And we'll try it out. And you know, this device still could be failing. This MPS W06. It's very possible. But that's why we have to test things. And rest assured, this amp is going to get severely tested. I'm going to put it through the dummy load, and I'm going to crank this thing up till it gets screaming hot, and then shut it off, let it cool down, and do it over again a few more times, just to make sure. I don't want this thing ever to come back. Not that it wasn't fun working on it, but let's zoom back out so you guys can see what's going on here. All right. And I do see chat comments too. I just keep switching screens, so sorry if I miss anything that's on there. I'm not even going to fully screw everything in. I'm going to put these in and make sure our ground is connected. I'm not going to get it really hot, so I'm just going to leave the little clamps off the transistors. I just want to make sure I can get an audio signal again. That is the plan. If I get an audio signal again, then we will look into throwing it all back together. I am missing a screw though. Where'd that screw go? I don't know how they disappear. There it is. It's just rusty and blended in with the other ones. Alright. Everything is somewhat screwed in. We went through the 15-volt supply. That seems to be what our problem was previously. It was our problem when we put this thing back together and turned it on. So now let's see if it's gone away. It appears to be working with the bench supply. So if it works with the bench supply, I'm going to ask it nicely to work with its own power. I wonder if I mean, this is a heavy amp. I don't know if my kickstand will hold this or not. Let's make sure it's not going to smush anything. Alright, yeah, we'll be okay. Big old beast of an amp. Alright, we're going to start off current limited for sure. Make sure that we're plugged back in. I'm actually going to lay it down first, because if it doesn't kick on right away, I want to be able to poke in there and see what's causing the issue. Just use my board over here to prop it up so I don't smash don't want to smash the knobs. Then that's more things that need to be replaced. Alright, there we go. Beautiful. Turn my iron off. Get our speaker hooked up. Cheap Tang Band speaker out of a Logitech Z5500. Works great for testing though. Alright. Those should be insulated terminals, but I'm too lazy to replace them right now. We're going to go to phase 0. Still going to stay in LFE mode. Volume's going to be all the way down. Frequency is going to be all the way up. And we need an audio source. Function generator, 40 hertz. Sine wave. Let's see what happens. Make sure that none of our outputs are shorted and that this little guy over here isn't touching anything he shouldn't. Alright. We have relay click. Oh, look at that. There's sound this time. We have resurrected it. I'm hoping it was a loose solder joint. But I do have output. I'm still current limited, and I'll show you what that means. I know I've had a few questions, even though I asked. Ignore the mess. I told you I got to clean my bench at the start, but I run power in through here on the bottom. I have an indicator light that says if it's on or off. I have this switch which goes directly to the outlet from the power, and then I have this switch up top which goes through this light bulb first and then to the outlet, and it limits the draw to the amp to only about 1 amp. So when I start to turn the volume up, you can see that bulb starts to glow and starts to limit the power going into the amp. It's just a kind of a safety measure, just to, one, to prevent from blowing things up, and two, to prevent me from getting hurt. So we have sound coming out. I'm going to kill the power and put the amp back together and see if we can get sound again. I don't know if it was a fluke. I don't know if it was just a loose connection. I don't really know what it was. I'm kind of baffled by that. I do want to drain the caps though, and I think I know an easier way to do that. So our diode bridge does go to our large caps, and our diode bridge is a little more accessible than the rest of the circuits. So what I'm going to do is I am going to go to one of the standoffs here, and then I'm going to go to each leg of the diode bridge going out. There's one leg, and there's the other. And I'm just doing that because in case I slip with something, I really don't want to short out one of the outputs or break this thing any more than it's been broken. So we are in the home stretch. And again, this thing still needs to be thoroughly tested. I want to make sure it's reliable before sending it back. Make sure I don't get any phone calls or hate mail. I'm gonna, I've had a few people email me, and I know I don't provide the schematics. The reason I do that is I don't want to get in like legal trouble. That stuff is available online, but it hasn't been released to the public yet. I am a huge advocate. I believe in right to repair. I know there's a movement going on right now for that. People should be able to repair the things that they pay their hard-earned money for. I don't see why, when you buy a device that you have to throw it in the garbage because, the company doesn't give you the information you need to repair it. That's ridiculous. So I am going to start sharing little snippets of the stuff that I find online. It's not really hard to find. If you look for it, you can find it fairly easily. But, it helps, people that are trying to learn some of this stuff to kind of show what I'm looking at to try and figure this out. Now, granted, not all these models have schematics. A lot of the stuff I work on doesn't. I just got lucky with this one, and it does. Figuring out that power supply issue would have taken a lot longer if I didn't have that information in front of me. I'm sure I would have eventually found it, but that involves tracing circuits, taking notes. You know, it's a lot more work. So I think we got lucky here. I think that, you know, that's part of the board that was severely damaged. I did a lot of rework in that area of the board, so I think that you know, I'm gonna chalk it up right now to a bad solder joint. Whether it was my solder joint or a factory solder joint or a solder joint that was ruined by all the corrosion, I don't know. I'll let everyone else vote on what the cause was. I just want to find the cure. Again, be kind of careful when you're tightening these things down. It's just a piece of stamped sheet metal. They are really crappy ways to clamp down MOSFETs. Like almost every amp uses them. I hate them. I like when you go right through the hole in the center of the MOSFET and use a little insulated bushing to isolate it. That seems to be the best way. But a lot of people like these. Well, I don't know who likes them, but a lot of companies like to use these clamps, probably because it's cheap. But I mean, they seem to work. They're easy to strip out, though. And then when you strip them out, you got to go to bigger holes and sometimes rethread them. It's kind of a pain. I guess you can drill them out and put nuts on them if you wanted to, but it's more work that I don't really want to have to do. I am going to re-glue them. I'm going to test it first, then I'm going to re-glue them. With my Technician's Loctite. My little weather stripping hold down seemed to work pretty good for this little thermal bead here. So that was kind of cool. Just make sure it's protected by the foam. You don't want to crush that. If you crush that, the amp won't work. It will trigger protection mode permanently. And you'll be wondering why and all upset that your amp doesn't work. And I'm eager to get this done because I can smell that my wife has dinner like almost ready. She's probably going to be yelling down here for me to come and eat, and I'm starving. So that will be a good turning point. So if you were watching when I panned the camera up towards my wall, I had two large resistors on my little board there. And that is a 4 ohm 300 watt silent speaker, I call it. It's a dummy load, but it's really a silent speaker. And what I am going to do is I am going to crank this bad boy up, and I'm going to let it run and get up to temperature for several hours, and basically cook the amp. I'm going to give it, you know, medium to high level output, and I'm just going to let it rip and do a little burn and make sure that, you know, there's no other bad joints on there. Cycle it a couple of times and see what happens. But for now, let's get it on the kickstand. And I know you guys can't hear the output, or if you can, you have better hearing than I do, because I can't usually hear it on the videos. We're going to flip it on again, make sure it still works. I did not hear relay clicking that time. What did I miss here? Maybe this thing just doesn't want to be screwed back together. The power leads are in. It's plugged in. Nothing. Why does this amp hate me? There's no way it's a bad output. Connections are good. Speakers are connected in. I wonder if that 15 volts went bad out or went out again. Good thing I didn't glue those. All right, let's flip it off. I'm gonna start by just unscrewing the two thermal sensors. Maybe something's acting up with those. It's triggering a shutdown or protection or start simple just with these. Let's see what the heck is going on here. I don't think it's either of those, but it could be. Try again. Not getting any juice. Oh, wait, hold on. This switch is off. Try again. I am not getting any relay action. Something else is not behaving. This guy is not firing. Sometimes a little tap can help. I'd be curious to see if the 15 volts is present or gone again. Let's see, we have pin 1 is there, ground is pin 7. 1, 2, 3, 4 in is 15 volts. So now I have plus 15, minus 15, so I don't have, the 15 volts is working. But I'm not getting relay click. Well, maybe it needs an input. Maybe it's audio sensing. Let's try that. That's probably what it is. It needs an audio signal to be happy. Speaker is still connected. Alright. Let's give it juice. Oh, there it is. Okay, so it needs a signal to get power. And we have audio output. So I am going to give you guys a little visual of the audio, and then I'm going to go eat. Because if I don't go upstairs in about 3 minutes, my wife's going to kill me. And then I won't be able to make any more videos. Because I will be dead. Alright, grab my little test clips here real quick. Give everybody a visual that this crazy amp is working again. And then I'm going to go eat. I am going to kill the power before hooking this up though, just to play it safe. Speaker minus. Speaker plus. Come on, get on there. I don't want to have to hold these. Stand by. Little clip is fighting me. It's okay to modify test leads for video reasons. Alright, we're clipped on. You can see the screen. We're going to give it juice. We have click, and we have audio. Now the reason that it's clipping is because I'm running current limited on the power supply, but you can see that the amp is working. It's at 44.493 hertz. I'm feeding it 40 hertz. That could be because it's not getting a full measurement because it's clipped because of the current limit. But we have output, and it may need some adjustments too on the amp, but we do have output and the amp is working. So I am going to go eat before I die, and I appreciate you guys tuning in. I'm glad you don't want me dead. I'm gonna go eat. I'm gonna be back later tonight. I have a Sunfire I need to finish. I have a couple of other hobby projects that I need to get done, and it's too hot outside to do anything else. So I appreciate you guys tuning in. Like and subscribe if you haven't done so. I might do some more testing with this when I get back. We will see, but for now I am going to go eat, and I will see you guys later. Thank you for tuning in, and I